So we have the stress strain curve that could also help us to understand how the material is going to act or will act under certain loads. And stress strain curves are different for different different materials, I should say. A few things that I just want to pay attention to when we look at this, and we're going to go over some of the details on the next slide. But when we see this here, 0 to A, that right there could help us calculate the modulus of elasticity, because we know that our rise here is stress and our run over there is strain. And we know with Hooke's law, that stress is proportionally related to strain. That's how we could find E. But as we go along this curve, there's different points that I just want to highlight, the more important ones really. We could get to a point where we've reached the elastic limit, where we know that anything within that range as far as loading, the member will be able to go back to its original shape and form. Once we go beyond that, we start going to the yield point, where now it's actually yielding in shape and we cannot go back to its original shape or form. And when I say go back, it means if we were to remove the load from this particular member, we would not be able to go back to what it originally was, because we've gone beyond that elastic limit. We've reached the yield point. Once we go beyond that and we continue to increase the load, then we're going to experience some, necking, let's say in the case of a tensile test, right? Some necking. And then as that load continues, then our cross-sectional area is even smaller and we get to a point of fracture. And again, for different materials, these curves are different, and they ultimately can help us understand how a material is going to act in different cases, and we could use that information in our various analyses. So if we look at this here, this is not in the handbook, but it's just a little step-by-step of what's happening if we have a member and we continue to increase the load. So here, this first one, we see that it's in its resting form. We have this original length, and we have the original cross-sectional area right here, and that's associated with this, right? It's at rest. So then we increase the load, and once we increase the load, then we know that the length is going to increase, right? So as it's increasing, then in this particular case, we're highlighting that we are at the yield strength. And you can see here how we have the Young's modulus, which is the slope, right? Rise divided by run, stress divided by strain. Now, as we continue to load this rod, this member, we are at this point where we're necking. We can see here that the center is getting a little bit smaller. That area is decreasing, right? And then as we continue to increase the load, we know that the length is getting longer still. But we get to a point where, with this increased load and this cross-sectional area becoming smaller, that stress is grand, right? It's greater. Therefore, we've reached a point where we are going to get a fracture. And then that's where we have this point there. So we have all of, these little points here that are important. And ultimately, when we are talking about this elastic deformation, we know that we're going to have some deformation, but we could return back to the original shape. All right. Once we start getting beyond that and we're going into the plastic deformation, then we know that that's going to happen across the entire member. Right. And from there, once we go beyond that and we get to the necking aspect of it, it's no longer uniform as far as deformation. That necking is occurring, and it's much smaller than the rest of the member, and it becomes obviously a point where we cannot return back to the original shape or form, and we get to the point of fracture. So with that, we will hear percent elongation or percent reduction in area. These are both on page 130 of 10.1. Percent elongation is just the strain multiplied by 100. Percent reduction in area is your initial area subtracted by the final area, divided by the initial, and then multiplied by 100.